Welcome everybody. This is part 3 for the Russian troll tweets. I'll leave 3 different time markers if you want to skip ahead or only view certain parts of this video. Feel free to hit me up here on Instagram and Twitter. If you'd like to help support the channel, here is my Patreon, or consider buying me a coffee. There's my handle for that. If you're trying to follow along, you're going to need to follow from the first notebook. Otherwise, you can pull directly from Kaggle to get the data set. Here's the basic imports that we're going to have for now. Just remember what these data look like from the last video. Here's the tweets that we have. We're going to be splitting off of this language right here. We're also going to be doing some formatting today, working with the author portion. From the first video, we took out the hyperlinks from each one of the tweets because it was unnecessary and mess us up later when we're doing a future video. We're going to be working with date time formats, as well as dealing with the time that each one of these tweets came from later in the video. We need to notice something since we're going to do some formatting real quick with hashtags, as well as the @ symbol calling a particular user as a reference. In this particular instance, we have 2 people letter referenced. So we have to make sure that we account for each one of those in our string processing, either using regular expressions or any other form of string extraction, such as this right here. If we were to use this, we would have a problem because it would only pull the first entry, and that's not what we want. We want to extract every instance after this @ symbol and store this later. So you can modify this and do extract all. Unfortunately, this returns a multi-index table. So unless you want to start messing around with that and trying to flatten or unnest it or unstack it, be my guest. I went a little different route. Since we're first going to look at figuring out how to parse the hashtags and the reference to a user, I created this little function where we're throwing in a data frame and then whatever pattern you're wanting to use. So I could zoom in a little bit, make this a little more legible for the people on mobile devices. So what I did was go through my data frame, and you'll have instances where it's not a string, or it's not read as a string because it's a null or an AND value or something else, some kind of weird symbols list not recognizing, like emojis or something, for instance. So I made this if statement and then threw in the option for the pattern that we're going to look for, and I'm using a regular expressions re.findAll, and then just append it in. Otherwise, if you don't have that string, just throw in a none. This allows us to work with both of the formatting. Therefore, I use the function that I just created, and I call in the column that has all of the tweets. From there, we're using our pattern to extract it and throw in a new column into our data frame, which is our referencing. So we can look at that real quick. So let's scroll over, and we're going to see that we have the hashtag and the tweet that you can use after you use this function. You just change the @ symbol to a hashtag, and then it'll store this, and it looks like we have none. But let's see how this looks. There we go. So here's one of our Russian ones. Then we do the same thing for the hashtags, the same exact procedure, cut and paste it, just change this right here, change the referencing, and then check in whatever column name you want. To do a verification that it's not none, here we are. So it lets you know that this did actually work. And in this case, it had multiple people for this tweet referencing. That's your sanity check to make sure that you're doing this correctly. I wanted to convert these strings to lowercase for the authors because we're going to do a comparison in a little bit, and that's going to help us out. So this is great because we just call in our column, and then we just run a map function and convert it and add it to our current author column. What I was interested in here, this is adapted code for these few lines right here, but really what I was interested in was figuring out, hey, if we have some kind of unique user or author, let's find out if they were the original person who threw out the tweet. That's what's going on with this apply function that's evaluating any instance of true. And I just printed off the tail version of this. But here are all the people. So here, Today in Syria was created or tweeted by this particular person. So we could figure out, well, what percentage of our data actually came from the same person who originally tweeted these data. And if you see, it's only 136 rows, which means that only 136 rows out of our subset data that was during the election time. If you don't remember from the last video, we subset from around October of 2016 till January 1st of 2017. And it was, I don't know, maybe, let's find out. video. So we got 500,000 rows, almost 500,000 rows. So out of that, only 136 came from the original person who tweeted these data. Then I had some interest in finding out how can we establish who has some form of influence. Using a follower ratio to following, we can set it up like this. You can use a numpy.where. This allows you to do basically a conditional statement, if-else statement, where we're looking through our particular column of followers and dividing it by the number of following. You have instances where you can have a user who is not following anybody, which would give you an infinite value. So we need to take care of that here. If it's infinite, just keep the number of followers. Otherwise, you do the division and you'll get a ratio. And what we found in the subset data of 500,000 tweets, that roughly 35.8% of them are from people with a high follower count, where the threshold was if their ratio was at least double follower to following. But what does this even mean? Since a user may have a large amount of people following them, that means that they may have a lot of influence. And as this ratio grows, they may have more influence. So I decided, let's find out who has the most influence in our data set. I took the column of the follow to follower ratio that we just built and sorted those values in descending order and took the top 10. And when we scroll over, you see this huge ratio here. All these people have a lot of followers. So we can scroll over and you can see here's the followers and here's the amount of people they follow. They don't follow anybody, so they're just tweeting out stuff or retweeting stuff. So it means that people are obviously listening to what they're saying. Then we could check the fraction of tweets which are actually retweets. Some users are purely retweeting. We will see that in a second to establish, are these top influencing people only doing retweets? What is the proportion of retweets they have? The problem with having a lot of people following, if you're producing some form of agenda or trying to persuade people, you can easily do it depending on what you cherry pick for your messages. That's how you can influence media, for instance. Let's first pull the column of English language, and that's what we're doing here. We print this off and we're going to start evaluating what proportion of the English follower to following count are basically the influencers, and it's 17.5%. This is the proportion value if you're using still the doubling of the ratio as your parameter. I did the same thing to look at the Russian troll tweets. We subset the column of Russian language and did the same exact thing, just cut and paste everything. And it turns out that you have quite a bit of people in the subset data for Russian language from October 2016 to January 2017 who were influencing people. Proportion of retweeted data from our original subset before we split by language was 72%, meaning that we had a great deal of our tweets that were just retweeted, which is really interesting. And then you notice that the English and Russian tweets are quite high. Let's look at the top Russian and English users by these ratios. If we went through and found the unique values for the author for the first 500 in descending order by sorting this column, these are the people or entities that we print off right here. A lot of these names look very common, like the same person was using the same name and changing the ending. I don't know what's going on with that. I don't speak Russian, so I don't know what it means. The English, these are the top 10 people who are influencing or retweeting data. Retweeting, I said, I didn't say producing original content. Here's the number of tweets that these people produced in the English language for the top 10 users that I did right here. I looked for anything that was a retweet. That's what the =1 means. =0 is not a retweet. It's any other kind of tweet. Then I did a value count and took the top 10, and that's what it is. Amazingly, these people have 11,000 to almost 3,000 tweets each. It's ridiculous. I have too much free time. Then I say, let's look through that and create it as a list and take those people and iterate through those names, where we're going to look at anything that's a retweet and we're going to take or those author or users and how many times they came up during this condition where we want to retweet and we want that person that we're iterating through independently and then we're going to divide by the length of it, of the retweets for that person. Let's say this again. We're taking each retweet, we're subsetting the data into retweets, then we're going through each of the authors from our list and we're dividing it by the number of retweets they had. So it looks like basically all of these people's data are retweets. This one's the lowest and it's 86.5%. Might as well say 87. So most of their data is just retweeted. Doing the same thing for the Russians. Here's the Russians, the number of tweets that they did for retweeted data based on the top 10 authors or users. Ran the same exact thing for this cut and paste. Same exact thing. And what we notice, basically all of these people are just retweeting the same junk as well. Now let's look at the top 10 tweets in general. There's a lot going on with this, so bear with me a second. Just pay attention. We're looking at subsetting the data by retweet. Then we're taking the author and we're doing a value count, which is going to give us in descending order the highest author who retweeted to the lowest, and we're only taking the top 20, and then we're using the index to get their actual name instead of the value. We're chucking that in right here using is_in, which is great because it allows you to take your list of information and subset your data based on those people's names. Then I take out the columns that I'm interested in here, which are these 4 columns. Make sure I only get the retweeted information. Now I'm only calling the author and the time and sorting the data by author first, then by the time, returning that data set. We can look at that real quick. So you first did the name, then you sorted by the time that they actually tweeted the data. From there, we want to look at the hours. What I did was go through and create something that's the same length. Let's print this out. I wanted to print out a list that's of the same length matching the user to the hour that they tweeted and then the frequency or number of tweets at that hour. That's what this is printing out. It has all 20 or whatever people, but this is only the first entry printed out, or first person for the 24 hours. Now, not every entry has 24 hours and we're going to have to deal with that. So we look at the author that we're iterating through, look at their time, get the value count for that, take the index, multiply by the length of it so we get the same length when we're running it through the data frame later. We're then taking that time, getting the values of that, and then we're getting also the occurrence, which is this. Now, since some of these are not 24 hours, only a few of these entries were less than 24 hours. But who's really tweeting 24 hours a day unless it's a bot just retweeting automatically, which I'm pretty sure is what's going on for most of this information. Therefore, we have to create this condition where if it's less than 24 entries, so for this particular name, we're getting the unique times that they have for each one of these people. If they don't have 24 entries, then we do a set difference. I took the full data set and made sure that it was 24 for unique values. If it wasn't, I would have did it by hand, hard-coded it, but I didn't have to in this case. Do the set difference from what we're evaluating for each person, and then we're going to zip together the hours that we're missing, and then we're going to address a 0 for that missing hour since there was no count. I did all of this because it's going to help us for plotting. And then I created the label names for the columns, threw it into a data frame, and then I took the original data that we did above, which is this, and then now our new data, this, which is counting for the set difference data that was missing. And I just appended it to the end of the data frame, and then I sorted by the name and the time, and that's what we get here. From there, we do some heat map clustering plots, which are pretty cool. I did this intentional, just in case you've never seen it or wanted to learn a new task. We throw in a default dictionary because I'm using key value pairs. The values are going to be lists. When we're iterating through this, let me show you what this looks like. This is what we're iterating through. Now, what we're interested in is snagging this and this. This will be my key. This is going to be my value. And each time I see one of these keys, I append a list with whatever its value is. So that's what's going on with this. I create a data frame from that, which is this. And here is what we created. I had to create an index because in order to make this work, I'm going to use on the columns, the hours of the day, and on the index, the name of the unique people. So this all matches up for our clustering map. you're going to notice these parameters here. These are useful because I wanted to preserve the ordering of the hours here, because if you don't throw it in, you're going to have your hours all jumbled around. So if we notice over here on the left for this dendrogram, you're going to notice that we have two distinct clusters, which you could look into. And we'll notice that these users, these two users on top, or really like these three users on top, are really some of the bigger influencers. And you notice they have some particular times in the day that they're actually tweeting, whereas some of these lower people, they don't have particular times and they tweet, at various times throughout the day. And they also, the number of occurrences of tweets are less than these right here, these lighter colored ones. If you look and see this, that's a frequency count. So you can get kind of an idea what's going on with some of these users. I did the same exact thing for the Russians. I'm not going to go over that again. It's the same thing. You just change this to Russian. Anything that was English, you just change it to Russian. And we'll see for the Russian one, it looks like there's nothing really going on in particular until you scroll down and you say, oh wow, these particular users down here have a lot of tweets. This is split up into what looks like two major clusters, and then they start branching out into small little factions. Remember that some of these are just bots retweeting junk. Let's look into how the larger retweeters are trickling down to other users. Let's take these data and subset it based on the top 10 retweets by author for English and for Russian. Like we saw before, we have quite a bit of tweets for each of these people. I think I already showed this part before, but now let's do some cleaning of these data. Now this looks like a jumbled mess. There's a lot of ways you could go about doing this, but here you can start subsetting your data and then just doing string replace for certain patterns so you don't get rid of every kind of pattern. Here is taking care of the hashtags. This is taking care of the people who were referenced, then separate hashtags that were not in there for people. Also the more @ symbols, a lot of these dashes were in there, and then miscellaneous other information that'll just come up that you could parse separately. Just depends on how you want your data. Do you want it to be absent of all symbols and everything? Then you could just go about this a little bit differently. This is more just using a use case for what you got currently as what's going on with this. Just pause the video and look at it if you're interested. Convert everything into lowercase. So we go through our data set and we're going to do a range length. And don't forget to convert this into values. And I did this so we could realize that we have a line by line interaction. And you have to verify if it's a string or not, because remember that some of the type of some of these are not string because they're symbols or they're empty or whatever it may be. And we take that value that we are iterating inside of, and if it's a string, just do a dot lower, convert it. Otherwise, just chuck in the original value for whatever it was and update this as a new column called kind of clean data. And when we do our value count, once again for this kind of clean data, making sure that it's a retweet, we'll notice that these are the top 10 retweets or whatever, and you'll see this isn't a string, it's a symbol. You'll notice that we still have some information here that could be taken care of in further processing, but who cares for now? We can say, all right, what else can we do? Let's illustrate this. I wanted to say, let's find some strings using substrings, which are Hillary or Trump or climate. Hillary, maybe it's an extra L. I iterate through anything that's not a retweet. So this is an original tweet, because what I'm going to do is look for the original tweets and then find out if those original tweets were retweeted and find those. So we found everything that's not a retweet, and we use the regular expression .search, which allow us to look through anything that was Trump. I didn't iterate through to find all of these. I just looked to the Trump thing, since that's what's current news right now anyway, just like in 2016, and throw in our iterator. And if we get that comparison to work and it's a string, just throw it into our list, and this is what we print off. Here's the first 5 entries of anything that came up that had the word Trump inside of it. We look through our data and take anything that's a retweet with our kind of clean and find good old Mr. Trump. And it turns out of the entries, we only have 378 occurrences, lower retweets. Since we know that, we can take that information and throw it into this new variable, Trump-Clinton climate change tweet, even though these two are irrelevant now since I didn't use them. And we can get the value count for those particular tweets, because I was thinking, well, let's get the most retweeted tweets. So it turns out it's these two, and that's what we're going to use for our further other printouts. So we check those, and we are now taking the top 20 list for our retweets. So from there, we could take our top tweets, only take the top 2 of them that we wanted above, and then we're going to find those within our data frame, and then we're going to sort by the date, and we need to reset the index so we could do some parsing. And what you'll notice if we scroll over, here's the Trump tweet. There's 2 of them. I just didn't print out the whole thing. And we're going to start parsing this by the time that it was actually tweeted here. We're going to convert this into a string time with this formatting so we can do some parsing. We split by the first and the second tweet based on the row position, which was easy since I reset the index. And you got to remember to reset this further index since you subset once again, because you're using this function where we're taking in the date and then you're throwing in whatever data you want and then the starting point. The starting point is what you're going to use for your time delta, which is here. This I is each one of the times that we're going to iterate through, and we're converting this time delta into a float value. You could just do int instead, but what we want is the minutes that elapsed after your first tweet. The first tweet usually, if the data is correct, is the original tweet, but in the first instance of the plot, that's not the case. Now I did this by 10,800 seconds, which is a few hours, 3-4 hours or whatever, and then I append that value, so we're left with a list of hours. So it'll be easy to look at when you see the plot. And then if it is longer than 3 hours, just chuck it in as nope, we're not going to use it anyway. And then you take all of that and you throw it in as a new column as minute integers. We do the same thing for the second tweet, and we plot it off with our first tweet data. The x-axis is your minute integers, your y is your authors, and then you're coloring by the tweet. So you'll notice that this world of authors, who is always chucking out retweets, in this case to the first one, and then you have all these little trolls that are coming in along the way retweeting all this garbage here, and this is your tweet right here. We do the same thing for the second tweet, and here's what this one looks like. Here's the first person that tweeted this off. This is the original person in this case, and then here's all the other people that are doing the retweets from there, from the minutes. So you notice that there's at least a pattern. If you ran this through multiple tweets, you get a pattern to figure out what's going on, and you could see what people are tweeting, what, etc. You get the point. This leads you to graph theory to figure out what the little network looks like. But that'll be the end of this video. So please like, share, and subscribe. And if you subscribe, turn on that notification bell. Feel free to hit me up here on Instagram and Twitter. Also, if you'd like to help support the channel, here's my Patreon, or consider buying me a coffee. See you in the next one. Bye.